First of all, I'd like to thank Professor Filceva for the invitation and her collaborators for putting together such an interesting meeting. I'm really glad to be here. The presentation I'm trying to give today is mainly the work of this guy here. Probably most of you know or heard about this guy, Claudio Zaccone, University of Foggia, Cesario Plaza from CSIC Madrid, Claudio Ciavatta from University of Bologna, and William Shoddick from University of Alberta, Canada. The work we tried to do is a sort of small project. We wanted to give a small contribution, as we have said in a recent occasion, also talking with Alessandro about the meaning of the humification, what humification can be, and trying also to present data that differ quite a bit from the humic substances versus organic decomposed or partially decomposed material as we found in peatland. I'll try to be short, like this guy is saying here, but probably I will not be so efficient in being so clear and fast. I also have to excuse myself because of the very intense scientific and relational activity that we have been having in the last days did not allow me to really refine and complete my presentation carefully as I should, as most of you have noticed. One interesting thing is that we're starting from the intriguing definition by Stevenson about humification, and also it's very interesting to give these ideas here today, coming back from the fact that it's more than 2 centuries that we have been extracting organic matter by solution, by alkaline solution. This is apparently now is becoming really very controversial. But this is extremely important when we talk about the biochemistry of carbon in peatlands, also because peatlands represent almost 1/3 of the entire carbon stock that we have at the global level. They are very interesting systems because peatland are an exception to the assumption of the recalcitrant organic matter controlling the long-term deposition and preservation, accumulation in mineral soils. And this is mainly because the amount of inorganic material that we have in peatlands, especially in peat bogs, it's really a very minor component, counting for a very few units, percentage units. Now it's very interesting when we talk about peat bogs because they have been really an excellent record of natural and anthropogenic changes of the environment, recording along the profile a number of information about the climate and the changing of the climate also at the paleo environmental level. So we usually, sample cores like this one in which even traces of dust and atmospheric deposition can be recorded according time. The real point is that if you look at the profile, these are slices along a profile, along depth, we would say, the result of the changing the rates of the atmospheric deposition really modify the profile of the organic carbon accumulation, but this can be affected not only by a natural or occasional event, but also by the difference in the rate of plant growth, for example, the botanical changes of the environment, and of course, the decomposition of the organic material. So there are many factors that affect these phenomena of accumulation and transformation can be observed with time. It's interesting to come back to shortly to an historical background. We have a few definitions. I think you cannot really read everything, but I mean it's interesting. We start from Kononova definition about humification and the humic substances. I mean most of the people are here actually. My case, Roger Swift in '78, Frank Stevenson, George Aiken, Alessandro in 2001, Sandro Piccolo, something here, I think. In the screen, Bob Bershaw, and then Schnitzer, and the final is 2018. What we found on the website about of our society, saying that humic substances are complex and heterogeneous mixtures of polydispersed material. Blah blah blah. This is very interesting, and it's very interesting to come back to this citation in late 50s of the last century. That says that one of the main reasons for this situation is the fact that we have no very clear conception of the meaning of the degree of humification, and we do not know what we really try to determine. Usually the studies on peat samples have been done comparing a small number of proxies or indexes that are compared, but and most of the cores usually come from the same place, so we have similar features. The effort that we have done in this study is to compare peat samples coming from completely different environment. It is a large number of samples, 40 samples, coming from 4 continents and completely different condition. And the other idea is to find a way of measuring with a very simple and immediate, fast, and low-cost tool to measure, to a certain extent, the degree of humification. The analysis that we have done on this sample come from the literature, and we have done a number of analyses that are related to physical and thermal approaches. You can see some of them, the chemical and spectroscopic approaches, and then we have done also some biological approaches, and then we also combine some of these data. So there are many, many analyses, starting from very simple indicators like the Van Post procedure, which is a very operational procedure to study the degree of humification of peatlands. It's actually a squeezing over the peat layer and measuring the turbidity of the water coming out, of the pore water. And going up to FTICR mass spec measurement, of course. Now, the methods that we collected, the material that we collected, so there are 9 different bogs from 4 continents. There are 3 from America, 1 from Asia, 4 from Europe, 1 from Oceania. And they have been selected according to the climatic composition, which is very different, the botanical composition, the extent of peat accumulation from 1 meter to 14 meters, depth, and the age of formation from few decades to 20K years. Then we have also used specific layers, 4 or 5 layers according to the depth, and therefore the number of samples, as you understand, increases, and then resulting in 40 total samples that we have analyzed with all the techniques I shortly mentioned before. Here we have some of the place. We have the Canadian one. We have the second Canadian, Sifton, Ontario. We have a place here in Argentina, south. We have a place in Fula Island, Shetlands, Scotland, Switzerland. Étange de la Gruyère is one example. I will show some of the data. The Italian famous floating peat in the central Italy, Borneo, Indonesia, and North Island in New Zealand. So these are the samples. These are the tests that we've done. We use different techniques. We measure depth, density, ash content, age, using gamma spectroscopy, atomic ratios, extractable humic substances, NMR parameters, ultraviolet parameters, specific UV absorption and extinction molar coefficient, fluorescence, molecular fluorescence, stable isotopes, and thermal analysis. All these analyses have been done. So we have accumulated most of the proxies. We also have statistically treated. We measure first the variability of each parameter, and we also observe that between the minimum and maximum, in some cases, we have 1 order of magnitude or more in difference. And this is some of the results. I only show the result of one pit book, saying that, showing all the analysis that we have done. And you can see that according to depth, we have all the parameters you can see of. That's better now. You see, we have a very large variability, either with depth and between the result of each of the sample. Going worse. Then we statistically treated the analysis. Now you can see all the data are accumulated statistically. It's not really a meta-analysis, but it's a very large analysis, and you can easily see the relationship that we have according to the different proxies and information that we obtained. And therefore, we can see, for example, that most of the data relate very well one to each other, probably because the vegetation forming the peat did not affect the parameters, or they affected in the same way. Or for example, some of the proxies are not correlated with depth and age. And this is very interesting because commonly, as we understand, depth is considered a measure of the age, because we are talking about accumulation of organic material with time in a vertical direction. But this did not work exactly very much. And also the humification degree is completely different in some cases. So CNA ratio does not work. Ash content and bulk density values as well, they cannot be connected. They don't relate at all. So also the stable isotope information are not related very much. What is very interesting is also the E4 E6 ratio. We have two authors of, I think, one of the most cited paper in the field here. And but as you may understand, the parameter has been studied for humic substances more than from the natural organic matter itself, and therefore this is probably why it's not matching that much. The remaining chemical, spectroscopic, thermal indices are quite consistent among each other. And this is very interesting also because we found out that actually 3/4 of the organic carbon in the peat, the samples that we examine, are comparatively in comparatively undecomposed states. So 75% of the total carbon is not decomposed. Now, in synthesis, we can say that the humification direction is indirectly related to the atomic ratios information and directly related to the extractable humic, the NMR results, the spectroscopic and thermal results. Now, the point is that we really need to find a way to have simple means of measuring humification, especially environmental parameters, and the reason is very important. Now, when we take a core of a peat, which is a lot of work, and it goes down meters in the ground, you need to analyze it, slicing it at least 1 centimeter. And if you take 10 square centimeters and you slice 1 centimeter, looking at the bulk density and the amount of water, which is approximately 95%, the amount of solid material that you obtain is very small. And from this small amount of material, you need to measure all the parameters and all using all the instruments and techniques that I mentioned. And some of the techniques need grams or many hundreds of milligrams for the measurement. Some of them are destructive, some are not. So, I mean, you need a lot of material. And this is not available in most of the cases because of a cost issue. Therefore, the material is insufficient. So, as the result, we can synthesize that, for example, atomic ratios is at the initial arrow, part of the arrow, in terms of the amount of material to be used, we ended up with the NMR material, not destructive, but at least hundreds of milligrams are needed. And in terms of cost, as well, atomic ratios are very interesting proxies. So which one will be the simplest, most effective and cheap, inexpensive method? HE ratio, probably H to C ratio, probably is the index that we can usually easily run in many laboratories with a very low cost, and also giving us, together with other elements, of course, the possibility of measuring also the degree of stability. You see the correlation, the regression coefficient, which is actually extremely high. But this is very interesting, because if we apply to this plot the age of the sample obtained with different measurement, you see the peaks here. You apply the third dimension, all the correlation disappear completely. So there is no relation between the parameter and the age of the sample. So this is a good proxy, a good compromise, H to C ratio. We can do replicates, we can have a large amount of sample to be analyzed, but we also can refer to thermal parameters, fluorescence, UV, and of course to more sophisticated techniques like NMR, or for example FT ion cyclotron resonance spectroscopy. But these are analyses that need very well equipped laboratory expertise and of course cost to get to this point. So most of the data are published, are going to be published soon in this paper, in Earth Science Review. And before closing, I really like to give my thought to a very close friend at the club that left us recently. He has been really a pillar of the society, of this community, and I think we should really owe him quite a lot, for us to be here today. So thank you very much.
Professor, thank you very much for a very clear and interesting subject and good presentation. Now we've got a few minutes for short questions, and if there are any questions, please ask our representative.
If any.
Okay. Teddy, you said that the H to C ratio would be a good indicator for humification, but normally...
In this kind of studies,
yes, but normally this is indicator for condensation, not so much for... It's used in the coal and the geochemistry and biochar community to see the degree of condensation of aromatics. But if you look, for example, with the NMR on the peat, you don't see this kind of condensation. So I'm a little bit astonished.
Well, the relation may be not so strong, but I mean, if you look at the entire picture and the application of this method to the specific kind of study, this is a good proxy. As I mentioned, other techniques are by far more informative and complete, but they need expertise, laboratories, people, money to be run. So I mean, of course, if you want to do, it's written somewhere, if you want to do a very detailed study, you need to use other techniques. This is really a very simple way of running out of the trouble. Pat?
Okay, just wanted to make a comment that you require 200 milligrams for C13NMR. Things have changed.
Yeah.
We can do...
That was just an example, yeah.
You can do that now with about 5 milligrams.
What, how many?
5.
5.
On your peats.
With all the machines? With all the machines?
Huh?
Are you talking about any average NMR available around? Or one of the best?
Yeah, it depends. They've made the rotors for solids NMR very small, and now there's one that's a 2.5 millimeter diameter. And with peat, what's nice with peat is it's very concentrated organic matter, and so you can actually get analyze the same amount of sample that you would need for, say, H to C analysis. And I don't disagree with you about the H to C.
No, the point is, if I bring you 100 sample, how much would you charge it?
Oh, well, we can talk about that later.
I'm kidding.
But I'm just saying that you don't need, it's not the most.
The amount of material probably.
The amount of material is not the
much
most
less,
anymore, okay?
And it's conservative. I mean, you don't destroy the material, right?
Yeah, exactly. You can do both H2C and NMR.
Okay, thanks.
Teodoro, so you mean that the higher is the HC ratio, the larger is the humification, right? Because you didn't really say that.
No, I didn't, yeah.
Well, this is very important.
Yeah.
Because in this case, it means that if it is true, it means that the humification means an increase in alkyl components instead of aromatic components.
Yeah, the point is that we are talking about raw material then, Alessandro. We're not talking about extracted. We're talking about the environmental deposit of the organic material itself, which is, again, can be differently decomposed at different levels.
The same thing, if you have an increase of hydrogen in comparison to carbon, then you must have more alkyl compounds with time.
Well, we probably have two, actually, if I remember one of those. Yeah. Is decreasing with humification. Yeah. Is indirectly related.
So as far as I understood, the ratio you
is
showed
indirectly
is
related.
Decreasing with humification. That means that hydrogen is decreasing with respect to carbon.
To carbon, of course.
So methyl, let's say,
I show that
with
the two arrows that with humification increases, we have a decrease in HE ratio. So it's an indirect relationship, whereas the other parameters have a direct.
Yeah, but anyway, the methyl should, hydrogen decrease, methyl decrease, carbon increase, aromaticity increase. Just roughly speaking. So,
Ladislao?
There is one more question.
Thank you. Congratulations, Ted. You have demonstrated some limitation of some techniques or parameters that are very commonly used. But from the point of view of structural or concept about humification, what you could add for us from the current knowledge?
No. What I said is very clear, I think, is that if you need a detailed and accurate investigation of specific samples, you need to add different techniques, and of course more sophisticated techniques may really add a lot more on the analysis, whereas this is like a review of all the methods we can use in order to analyze a large amount of a big number of samples, environmental samples, in specific conditions in which the amount of individual sample is very extremely limited. That's it. Yes.
Thank you. Teddy, you told us very nice about the humification process, but as a process of changing of natural organic matter into humic substances. Very often you can find humification degree of humic substances. How would you
humification of?
Humification degree of humic substances.
But this is,
Yeah. What can you define the humification process of humic substances? It's very some controversial.
I don't want to add any other definition. We have a list of definitions, and here there are so many people, But I would stick with the one given by the society recently in 2018. I have to, in a way, but this is an accumulation of dispersed molecular compounds that may have.
But it's not always is going to be more complicated. Sometimes it's not really.
It can be simpler. It can be simpler.
Okay. Sure. Thank you very much.
No, I don't want to add anything about that in this respect. Yeah, this is referred to peat mainly. Is that okay?
Thank you very much for all questions.